Within the realm of cryptography, CRAM-MD5 serves as a challenge response authentication mechanism rooted in the HMAC-MD5 algorithm. It acts as a component of the Simple Authentication and Security Layer, SASL, commonly integrated into email systems for SMTP authentication, safeguarding POP and IMAP user authentication, and utilized in applications supporting LDAP, XMPP, BP, and similar protocols. CRAM-MD5 is favored over less secure methods like login and plain when software necessitates authentication over non-secure connections. Nonetheless, it falls short in thwarting password derivation, making it less robust compared to approaches that eliminate passwords entirely or rely on connections secured by transport layer security, TLS. Adhering to the CRAM-MD5 protocol involves a single challenge and response exchange, commencing with the server issuing a base 64 encoded string to the client, typically in the structure of a message ID email header, value encompassing random digits, a timestamp, and the server's fully qualified domain name. In response, the client generates a string by decoding the challenge, hashing it using HMAC-MD5 with a shared secret, commonly the user's password or a hash thereof, converting the resulting hash into lowercase hex digits, and prepending the username along with a space character before base 64 encoding and transmitting the concatenation back to the server. Authentication is deemed successful if the response matches the server's expected counterpart. The inherent strength of CRAM-MD5 lies in the one-way hash function and the unpredictable nature of the challenge, delivering authentication, replay prevention, and maintaining password secrecy. These facets collectively bolster the security of the mechanism during the authentication process. Mutual authentication is not performed with CRAM-MD5 authentication, as the client does not verify the server's identity. However, in most cases, CRAM-MD5 authentication occurs within a TLS connection, allowing for server identity verification. Some implementations may store weak passwords, requiring access to users' plain text passwords. Others, like Dovecot, employ the HMAC process to store the MD5 hash of the password using intermediate steps, such as IKeyPad and OKeyPad. These implementations take advantage of the Merkle-Damgård usage in MD5, where only certain components are necessary for computing MD5 something with 64 bytes, somethingles. Despite offering authentication, CRAM-MD5 does not establish a secret shared between endpoints hidden. The CRAM-MD5 protocol is defined in the IETF Standards Track document, RFC 2195, and is used for authentication in email mailbox management protocols like POP and IMAP. The protocol is supported by the Simple Authentication and Security Layer, SASL, as described in RFC 4422. While CRAM-MD5 is included in the IANA's SASL Mechanisms Registry, it has become outdated over time. In a recommendation from November 20, 2008, it was suggested to deprecate CRAM-MD5 in favor of more secure alternatives like SCRAM or SESL plain with TLS protection.